Hello again, and welcome to the second part of this lecture. We have already covered correlation, and so now we're going to discuss about linear regression analysis. In this class, we're not going to learn about non-linear regression analysis unless you are taking QSO 520, the management of spreadsheets. We will discuss application of solver to non-linear regression analysis. So to start with, we're going to look at what we call single linear regression analysis or bivariate linear regression analysis, and then we'll move on to multivariate or multiple linear regression analysis. And remember, we are looking at the relationship between variables. And so let's see that we have two variables, y and x. And the kind of relationship that we're going to explain here is y depends on x to occur. So we can say that y is a dependent variable that depends on x to occur, but x is independent, meaning that it doesn't depend on y to occur. And so we can write this as y is a function of x. Remember, when we learned about probability, we saw one probability rule, which is conditional probability, where we say that probability of y to occur given that x occurs. So it's more or less the same as what we are discussing today, that y depends on x to occur, or y is a function of x. So in this case, we are looking at the changes in y as a result of changes in x. So if x changes per unit, by how much y changes? And so we'll look at that change in y. So we can say y2 minus y1, meaning that y will change from y1 to y2 as a result of changes in x. So we have x2 minus x1, meaning that we will look at the change from x1 to x2, and this one is per unit, or we say per unit change. And so by how much y will change? And the answer is y will change by the slope. So this is actually the formula for the slope. We can write either m or we can write b. So today I'm going to write b to indicate the slope. So when x changes per unit, y will change by the slope of x. So it is important to note that there is a value of y that will occur regardless x changes. And so this value, we can call it a, or we can call it y in there. So a good example of this is when we look at the salary, or here we're talking about salary actually. So this is the amount which employee will earn regardless of any changes. Let's say having years of experience, years employed, education, gender, department, and or number supervised. It is the value that occurs without it, depending on any change from any variable. But now if you have education and some other features, then they will add from that minimum wage. And so that's what we call the y-intercept, and we can write it as a in this case. So having y-intercept, we can write our model as y equals to y-intercept plus slope times x. So that's what we call single linear regression model, or we can say it is a bivariate linear regression model. And in this case, we can see that y is depending only on one variable, but there is this value of y which should occur regardless there is a change in x. But that value, we can add any change in x times the slope of change in x, and that will be the additional to the y-intercept. And so we can call this single linear regression model or bivariate linear regression model. You should note also that y does not depend only on x to occur. It may depend on some other factors, and so that will be taken care of by the error term. And so we can write y equals to a, or y-intercept plus the slope times x plus the error term, or we call it residual. So we can make estimation of y. For instance, we can estimate any of these salaries depending on these variables. So we can write like y estimate equals to a plus the slope times x. We won't include the error term because this is what we can estimate the existing salary, and the remainder will be the error term, or we call it residual. Sometimes we can overestimate the value of y, or we can underestimate the value of y. And so the remainder or the residual will be taken care of by the error term. And so this is the model for estimation, and we can use this model to estimate any of the salaries that we have, or I'll say that is the model that we can use for estimation. So before we do the estimation, or we need to come up with the hypothesis. Remember, with the correlation, we had to come up with the hypothesis. And so here also we need to hypothesize the estimation of y. And so null hypothesis, the slope is 0. And this one we can also give it a probability. Mostly if its probability is not given, then we can take the default, which is 95%. And we can write alternative hypotheses where slope is not equal to 0. It is significantly different from 0. And we can support this by the probability value, which is less or equal to significance level, which is 5%. And let me highlight this. We can test this hypothesis